Assalamualaikum and hi. Today we are from Group 2, Section 3, are going to present to you about our setting up project for subject PNP 21303 Geomatic Engineering Technology. So, as you can see here, this is our team members that consists of me, Nurul Syahada binti Zaita, Chelsea Ines Arangkong, Kishan anak lelaki Yogesh Warren, Muhammad Hakim bin Abdul Razak, T. Beng Siu, and lastly Ahmad Daniel Shafiq bin Ahmad Husni. To continue our presentation today, I will explain to you about our introduction for setting up project. Building construction is a complex process that requires meticulous planning and precise execution. One crucial step in this process is setting out, which is establishes the precise location and dimension of various elements of a building on the construction site. The setting out phase lays the foundation for the entire construction project and ensure accuracy, alignment and adherence to the architectural and engineering designs. During the setting out process, professionals such as surveyors and engineers work in collaboration with architect and contractor to translate the design plan from paper to the physical site. This is the theory of our setting out project. The theory behind setting out a building involves applying fundamental principles of geometry, trigonometry, and surveying techniques to accurately translate architectural plans onto the construction site. It encompasses various concepts and methods that ensure the proper positioning, dimension, and alignment of building elements. Setting out begins with establishing a coordinate system on the construction site. This involves selecting a reference point, often called the benchmark or control point, from which all measurements and position will be determined. The coordinate system can be based on local geodetic coordinates or a local grid system, depending on the project requirements.
For the equipment, we use total station, mini prism, tripod, tab, hole, pads, and the nails for our setting up project. Now I will present about our procedure of setting up project. First, a total station and a data required to the BS station was set up at the selected control station. Second, we use tape to measure the distance to the first pad of the building B1 by driving a pad at that point with a nail on top. The tape is being held by one person at the instrument point and by another person over the B1 pad. Third, the distance and bearing was checked with the mini prism. The pad was adjusted until it's aligned with the calculated bearing. Next, we straight the tape up and Y to get the position of the second pad. The above procedure is repeated in B2 and all corners of the building. Lastly, all the building lines were measured and the actual distance were recorded.
I am Kishan Yogeswaran and I'll be presenting regarding the result that we have obtained throughout our setting up project. By starting, we complete the intended building's whole purpose. We need to make sure that the spread was precisely the same as what was depicted in the drawing. To confirm the distance, we have used algebra and tape measuring. Apart from that, the triangle method was used by our team to calculate. We used tape measure to set out and calculate the distance between each pair of points, and our development is shown in the plotting section if you refer to the drawing. And here is showed that our data we have obtained or result we have obtained throughout our setting out project. At first, we used our components such as total station, mini prism, and also prism to set up from station to checkpoints. Here, from station 4 to B1, we have obtained the bearing 289 degree, 0 minutes and 45 seconds, and our horizontal distance from station 4 to B1 would be 3.611 meter. And moving forward to station B1 and 4 as the checkpoint, we have obtained 109 degree, 0 minutes and 45 seconds. And the distance are similar to the first one because it is the same station and same checkpoint, 3.61, 3.6 111 meter. And moving on to B1 as station and B2 as checkpoint, we've obtained our bearing 241 degrees, 32 minutes, and 1 seconds. And our horizontal distance was 6 meter. Moving onward to B1 as station and B3 as our checkpoint, we've obtained 259 degree, 58 minutes, and 6 seconds. And the horizontal distance for that is 6.325 meters. And going on to B1 as station and B4 as checkpoint, we have obtained our degree 275 degree, 13 minutes, and 25 seconds. Apparently, the distance horizontal distance was 3.606 meter. And nextly, from station B1 to B5, our bearing would have come out as 295 degree, 39 minutes, and 49 seconds, resulting on our horizontal distance as 5 meter. And finally, B1 to B6, we have obtained our bearing 331 degree, 32 minutes, and 1 seconds, resulting the horizontal distance as 3.970 meters. Nextly, I'll be presenting on the calculation of horizontal distance and also bearing. Firstly, for horizontal distance, to obtain the solution, we have to use a trigonometry formula. So here you can see as shown in the table, and the formula that we have used is from B1 to B5, from station B1 to B5, we have used the trigonometry and obtained our distance as 5 meter. And secondly, from B1 to B4, similar trigonometric formula, and we've obtained 3.606 meter. And in the table is shown for the calculation result is shown for from station 1 to our checkpoints, respectively B2, B3, B4, B5, and B6. So from station 1 to B2, our on-site distance in meters was 6 meter, and after doing the manual calculation with the trigonometric formula, we have obtained the same 6 meter as the result, and there's no difference in this length. And moving on to B1 to B3, our on-site distance was 6.325 meters, and also our manual calculation has tallied with the trigonometric formula. We obtained 6.325 meter as well, and there's no difference in this length. From station B1 to B4, we have obtained a similar on-site distance and manual calculation, which is 3.606 meters. And from B1 to B5 is also a same on-site distance and manual calculation. We have obtained 5 meter. There's no difference as well. But from station B1 to B6, our on-site distance was 3.970 meters. Our manual calculation resulted for on 4 meters. And there was difference because we obtained different result throughout the trigonometric calculation, and the difference is 0.03 meters. And following up with the bearing calculation, we have got the solutions as shown in this table. So to obtain the bearing, we have to use the tan angle formula to obtain the on-site bearing. From station B1 to B2, our on-site bearing was 241 degree, 32 minutes, and 1 seconds. And our manual calculation resulted on 0 because it is a horizontal line. And following up to B1 to B3, our on-site bearing was 259 degree, 58 minutes, and 6 seconds. And our manual calculation is we have resulted in 90 degree, 19 minutes, and 0 seconds, which you can see above that I've shown from angle B1 to B3, resulting tan degree and 0 degree, 19 minutes, and 0 seconds plus 90 degree, which resulted on 90 degrees, 19 minutes, and 0 seconds. From B1 to B4, our on-site bearing is 275 degree, 13 minutes, and 25 seconds. And based on our manual calculation, we have obtained 90 degree 31 minutes and 4 seconds. Similarly to B1 to B5, our on-site bearing was 294 degrees 39 minutes and 49 seconds. Resulting on our manual calculation, we've obtained 90 degrees 43 minutes and 50 seconds. And lastly, from station B1 to point B6, our on-site bearing was 331 degree 32 minutes and 1 seconds, and our manual calculation is 90 degree because B1 to B6 was a 90 degree bearing.
Good day to Encik Shuko and Encik Syed Farid. I am Chelsea Ines and I'm going to present for plotting. B1 to B2 is 6 meter, B2 to B3 is 1.9 meter, B3 to B4 is 3.1 meter, B4 to B5 is 1.9 meter, B5 to B6 is 2.9 meter, B6 to B1 is 3.970 meter. B1 to B3 is 6.325 meter, B1 to B4 is 3.606 meter, while B1 to B5 is 1.9 meter. This is the map for plotting at TBM2.
For discussion, the use of total station for setting out surveys in this lab experiment was effective and beneficial. The objective of the experiment was to evaluate the accuracy and efficiency of total station in establishing reference point and position. The result obtained during the experiment demonstrated that the total station instrument provided precise and accurate measurement. This accuracy is crucial for ensuring reliable survey data. The total station also proved to be efficient, significantly reducing the time required for data collection compared to manual methods. Its ability to swiftly and accurately measure angles and distance contribute to more efficient surveying process. In conclusion, the use of total station for setting out surveys proved to be accurate and efficient.
Hi, I am Ahmad Daniel. For the last one is conclusion. Setting out surveying is a crucial step in the building process. This is done by using surveying instrument which is total station to measure distance and angle and then marking out the position of the structure on the ground. After calculate the distance, we use tape to measure every distance from point to point. In order to draw a conclusion, we discovered that setting out is crucial to civil engineering work. Setting out is a supplement to a tachymetry survey since using this technique, we may locate any open area by consulting the tachymetry plan. When organizing the laying out procedure, we must also consider the site characteristics such as the existence of trees or other barriers. The location of the infrastructure can be determined once the setting house is complete. The setting point is situated in a sizable area that includes the traversing area. When all of the project is complete, we make understand the setting up procedure and how to determine bearing and distance based on an aim, and we can use this knowledge for future project. That's all from us. Thank you.